Number 71 in your class trick for the unit circle. We have a value of sine theta as negative 1/4, and we know the terminal point is in the fourth quadrant. So we have a case that looks like this. We have a point that is in the fourth quadrant, so it has to occur somewhere here. Then sine of theta we know is negative 1/4. So if this is opposite over hypotenuse, then we know our opposite side is going to be negative 1 in the y direction, so this will be negative 1. And our hypotenuse will be of a length 4. So this is 4, this is negative 1. And if we want to find this x distance, then we can construct a triangle and solve that distance from the Pythagorean theorem. So we know that hypotenuse squared, 4 squared, is equal to negative 1 squared plus b squared. So rearranging for b squared, we have 4 squared minus negative 1 squared, which is 16 minus 1. Taking the square root of that, we have b as the square root of 15. So now we can, and there's no way to rationalize square root of 15, so we can leave it as that. Now, if we know that our theta is this angle here, and this side length is of negative 1, and this is square root of 15. Now I can go ahead and solve for our 5 trig function values. So cosine theta is going to be adjacent over hypotenuse, which is square root of 15/4. Tangent of theta is going to be opposite over adjacent, which is negative 1 over square root of 15. Rationalizing that is going to be negative square root of 15/15. Then cosecant of theta is equal to 1 over sine of theta. So it's the reciprocal of sine of theta. So we just take the reciprocal of negative 1/4, which is going to be negative 4/1, which is negative 4. Then secant theta is equal to 1 over cosine of theta. So it's the reciprocal of cosine theta, which will be 4 over square root of 15. And rationalizing that, that'll be 4 times square root of 15/15. And then cotangent of theta is the reciprocal of tangent of theta. So that's going to be equal to square root of 15 over negative 1, which is just the negative square root of 15. So these are our 5 trig function values.